This brief tutorial will illustrate the two different ways which tendons may be specified. One, as only a load, and two, as a load with element properties. Our model will consist of two frame objects. We will use the same cross section for each, a 10-inch by 20-inch concrete section. The first frame will have a tendon modeled as only a load. The second frame will have a tendon modeled as an element, and both tendons will have an area of 1 square inch. Initially, no losses will be included. We start by going to the Define Frame Sections command. Here we select Concrete and click on the rectangular button. For our section, we will use a depth of 20 inches and a width of 10 inches. Next, we will draw the frame objects. We draw both frame objects from the outside in so that the local eye joints will be on the outside. Next, we select the outside joints and assign a roller support. The inside joint gets a pin support. Now we will define a load case for the tendon load. We will delete the dead load case as it is not needed. Next, we will define our tendons. We will add two new tendons. Our first tendon we will call loads, and it will be modeled as a load only. We can specify tendons by diameter or area, and in this case we will use an area of 1 inch square. Although this tendon is not an element, an area is still required for the calculation of loads and losses. Our second tendon will be called elements, and it will be modeled as an element. And it will also have an area of 1 inch square. Next, we will draw the tendons. The span on the left will get the loads tendon. And here we specify a tendon force. We will jack from the eye end, and loads may be specified either as a force or stress, and hence why you need an area to be defined. Here we will specify a force of 10 kips. For this particular model, we will set all the loss parameters equal to 0. For the right span, we will draw the elements tendon. We draw the tendons in the same direction as the frame objects. Again, we specify a tendon force of 10 kips and leave all loss parameters set to 0, although the other loss parameters section are applicable only to tendons treated as loads and thus would be ignored for this tendon. We are now ready to run the analysis. We will shut off the modal case as we are interested in only the tendon case. A right-click on the far left joint shows a displacement of 0.00139 inches in the X direction. This is for the frame with a tendon that is modeled as a load only. The joint on the far right moves in the minus X direction 0.00133 inches. Why the difference if the sections and tendon forces are the same? It is because the tendon on the right is modeled as an element and has relaxation due to its shortening. Next, we will display axial forces. A right-click on the frame object on the left shows that the entire 10 kips of tendon force is being carried as a compression force in the frame object. The force in the tendon element on the right is only 9.613 kips due to relaxation. By statics, the force in the frame object should be equal and opposite, and a right-click on the frame shows this to be true. We can get the frame on the left to match the frame on the right by applying an elastic shortening stress of 0.387 KSI. We do this by first unlocking the model and then selecting the tendon on the left and deleting it. We will redraw the tendon, again using the modeled as loads tendon. And will apply the same 10 kip force. All the friction and anchorage losses will be set to 0, but the elastic shortening stress will be set to 0.387 KSI. This is the relaxation from the element tendon divided by the tendon area. All the rest of the losses will be set to 0. We leave the draw mode and rerun the analysis. A right-click on the left node shows that the displacement is 0.00133 inches, which matches that on the right. The axial forces are also the same now at 9.613 kips on both sides. In summary, specifying how the tendons are to be modeled, either as loads or as elements, may have a significant effect on the distribution of loads and model behavior if the structure is indeterminate. This concludes this tutorial.